calculus. And this is mainly addressed to students who are going to take calculus at the university level for the first time. And this is assuming that you don't know any calculus, but you need to because it's, well, you either want to or it's prerequisite for your major. Maybe you're considering majoring in a STEM field and you need calculus, or maybe you just are majoring in a non-STEM field and you still need calculus. Uh, and you want to do well, and you may have heard things about calculus, and this is for the first semester. And how do you prepare? And this is a question that I see a lot. Um, you know, it might be a student who took math a long time ago, and now they are going to take calculus, but they don't remember a lot of their algebra and pre-calculus. How are they going to do well in calculus? Um, and I'm assuming that this is going to be a semester-long class. So, typically it will be initially about limits and derivatives, and then integrals. And usually the integrals in the first semester, it's sort of like an introduction to integrals. You should get to the fundamental theorem of calculus and maybe use substitution, or substitution technique for integration is usually the end. So this is assuming that this is like a 15-week class, or 13 to 15-week class. And I'm assuming that this is not the honors calculus class, which is more based on proofs and a very theoretical. So I'm assuming that this is mainly a class taken by non-math majors. So I'm assuming that you are someone who is not going to major in just mathematics. You're going to major in like engineering or computer science or something like that, biology, and you need calculus. So how do you prepare for calculus? So let's talk about just the math background. I'll probably make other videos about kind of just non-math background, so stuff like how to be prepared for a big university class. And also I'm assuming that you are not taking this at like a small college where the class sizes is 25 or something. It's more like 250. I'll make a video on this topic a different time. Okay, so let's talk about the math background. So it depends on which calculus class you're taking. So for instance, if you're taking business calculus class, you usually just need algebra and no trigonometry. But if you're taking kind of the main calculus class, so this is just like calculus, it's not calculus for business, it's not calculus for life science, it's just calculus. If you're taking a class like that, then you do need to know some trigonometry, and you do need to know some algebra. So those are the main things you need to know. So the math background is algebra and trigonometry. And trigonometry is usually called pre-calculus. And I'm assuming that the textbook you'll use is one of those big textbooks. So like Stewart's textbook, that's a very common choice. There's also a calculus book by Briggs and Cochrane. There's a one by Anton, and there's lots of different calculus books. There's one by Rogowski. Anyway, the point is that it's one of those textbooks that costs well over $100, and if you're taking it at a university, you'll probably do homework on an online site, so either something like WebAssign or MyLabMath, which is integrated with the textbook. Okay, so for this, algebra and trigonometry is what students struggle with. So instead of going over all of algebra and trigonometry, let me just give you some examples of common mistakes that I see, and I'm someone who's graded a bunch of calculus exams in the past. Some of the common mistakes I see. Okay, just working with students and seeing what they write. So one of the common mistakes is simplifying things incorrectly. So for instance, a student might write something like, so let's just go over common mistakes. Okay, so one common mistake would be, actually this is probably one of the most common mistakes, the simplifying incorrectly. So for instance, let's say that you had something like, I don't know, x squared plus x plus 1 over x plus 1. Something like that, right? So some students might just, well, they'll do all sorts of things, but you know, you might see students just like kind of just cross stuff out. That's basically the common mistake, right? The common mistake isn't so much simplifying incorrectly, it's more just like crossing random things out. And you know, let's talk about what crossing something out really means mathematically, because I think a lot of students don't even understand that. Okay, so you know, so this is wrong. Okay, in fact, the expression that I wrote doesn't simplify. That's as simplified as you can make it. So, you know, if you have some expression, okay, like x squared plus 3, I don't know, I just made it up. Okay, if you multiply and divide by something, so like let's say you multiply by x squared and divide by x squared. Okay, if you multiply by something and divide by something, you're really just multiplying by 1. Okay, well, if you multiply by 1, okay, you're not changing what you had before, right? If you take something and multiply it by 1, it stays the same. So if you have this, okay, this is the same. I started out with x squared plus 3 and then multiplied and divided by x squared. I just multiplied by 1, so this is going to equal x squared plus 3. And by the way, this is assuming that x is not 0, right? Because if x were 0, then well, you can't multiply and divide by 0, right? Because dividing by 0 is undefined. So this statement is correct. So you know, while a lot of students see, so you can cancel as long as you have a factor. You can cancel if you have a factor on the top and bottom, right? Here I have x squared plus 3 times. I have multiplication, x squared, and then I divide it by x squared. On the top, here, you do not have multiplication, right? This numerator, x squared plus x plus 1, I don't have something times something else. Okay, that's a common mistake. So basically, you know, I think a lot of students just kind of, when they get something they don't know what to do, they just kind of randomly start canceling things out. You know, like they get an expression that looks complicated and they know it's not the final expression and they're supposed to simplify it, but they don't know what to do, and then they just like cancel stuff out. And you know, before you cancel anything out, just ask yourself, okay, do I actually have a factor, the same factor on the top and bottom? Am I multiplying and dividing by the same thing? You know, am I multiplying by 1, right? Okay, don't just randomly cancel stuff out. I think another reason why people cancel stuff out incorrectly is because they see people canceling. They might see their teacher or professor canceling stuff out, and they don't know why it's allowed. So an example would be like, let's say that you had, I don't know, here's something, e to the minus 2x times x squared minus 1 equals 0. Okay, so this is something that you might see when you get to the section on critical points. So you take critical points is something that you might be able to find if you take the derivative and set it equal to 0, and you might get something like this, equals 0, and then at this point, okay, what's going on is you have two things being multiplied by each other, right? You have this thing, e to the minus 2x, that is being multiplied by x squared minus 1, and it equals 0. So what do you know about if you have two numbers and you multiply them and you get 0? what can you say about those numbers? Okay, one of them has to be 0. Right? You can't take two numbers that are both not 0 and then multiply them and somehow get 0. So if you have two quantities and you multiply them and you get 0, this is what we have, then one of them must be 0. So basically when you have something like this, what you would do is you draw a squiggle and then set each of these things equal to 0. So e to the minus 2x equals 0, x squared minus 1 equals 0. Okay, now let's look at the left-hand side. E to the minus 2x equals 0. Does this have any solutions for x? The answer is no. This has no solutions for x. Why? Because e is a positive number, okay? E is like 2.7 something, and when you raise it to a power, you can't get 0. Okay, in general, if you have a positive number and you raise it to a power, you can't get 0. And so that's why e to the minus 2x can't be 0. So there's no solutions here. On the other side, okay, there's a couple things you can do. One thing you can do is you can add 1 to both sides, and then, so one way to do it would be to add 1 to both sides. X squared is 1, and now what's x equal to? Now it's not just 1, so this is another common mistake. So sometimes students will get x squared equals 1 and say x has to be 1. In reality, x can be plus or minus 1. X can be 1 or negative 1. Right. So the solutions, so if the question was to solve this equation, that means find all the x's that make this equation true. It's gonna be 1 and negative 1. Right. Now what a teacher might do, so here I'm writing out all the steps. Okay. What a teacher might do when they see this, e to the minus 2x times x squared minus 1 equals 0, is they might just cross that out. Right? And, that's not a good habit. Okay? I hope you don't do that. Because why do you cross it out? Right? It's not clear. If you just cross, you can't just randomly cross things out for no reason, right? Right? I mean, there has to be some sort of reason. And that's why I don't like crossing things out in general, unless you have a factor on the top and bottom. And here you don't, right? So, the reason why you can just consider x squared minus 1 and just forget the e to the minus 2x is that e to the minus 2x equals 0 has no solutions. But I always prefer writing all this out. Okay. And just another good habit to get into is, let's say that you have something like x cubed plus x squared minus x all over x, right? Now, what a lot of people will do is they'll just cancel out x terms on the top and bottom. So again, I've already mentioned the previous mistake would be just to cancel out these x's, right? That's not correct. Okay, what you can do if you have something like this, and again, why is it not correct? Because you don't have a factor of x on the top and bottom. But what you can do is you can factor the top, right? You can factor out an x, and then get x squared plus x minus 1, and then all over x. Now once you're here, then it is okay to cancel because I have a factor of x here. I have an x times x squared plus x minus 1, right? And I have an x on the bottom. So I have, this is x squared plus x minus 1 multiplied by x on the top, and then divided by x. You multiply and divide by x, you're just multiplying by 1. So then this is equal to x squared plus x minus 1. Okay? Again, assuming that x is not 0, right? Because if x is 0, then this would be undefined. This guy is undefined when and x is not 0, but this guy is defined. X squared plus x minus 1 is defined when x is not, sorry, this should say when x equals, right? When x equals 0. And this is also defined when x equals 0. Right, so, okay, sorry. The left-hand side is undefined when x is 0. The right-hand side is defined when x equals 0. So they're not the same thing when x equals 0. Anyway, so that's a common mistake that I see. Okay, so just don't cancel stuff out. Just, in general, don't cancel stuff out unless you have a factor on the top and bottom, right? Okay, it's not a good practice to just randomly cancel things out unless you're really sure that that step is allowed. Well, I don't want to make this video too long. Another common mistake is probably just not knowing how to not knowing some facts about natural log, for instance. I mean, there's lots and lots of algebra mistakes. But for instance, if you have the natural log of like x squared plus 2x plus 7, okay, a lot of people will take the natural log of x squared plus the natural log of 2x plus the natural log of 7. That's not correct. These two are not the same. In general, you cannot split things up like this. What is true, though, is if you have the fact is, okay, that if x and y, say, are positive numbers, then the natural log of x times y is equal to the natural log of x plus the natural log of y. This is true. So the natural log turns products, right? X times y is a product. Okay? When you do the natural log of a product of positive numbers, you get the sum of the individual natural logs. So natural logs might be something you want to review. Natural logs show up in the section on implicit differentiation. So this is usually after you learn the chain rule. One example is implicit differentiation. It's not the same as the chain rule, but it's based on the chain rule. And then logarithmic differentiation. Okay, so that's a common mistake with a natural log. And of course, with the exponents, there's always this typical issue, right? You know, if you have x plus 3 in parentheses squared, it's not equal to x squared plus 9, right? What is the correct way to do it? It's x plus 3 times x plus 3. You have to distribute. You have to use the distributive property. This is going to be x times x is x squared, right? And then x times 3 is 3x. And then you take 3 times x, and then 3 times 3, so it's plus 3x plus 3 times 3 is 9. And then this is going to be x squared plus 6x plus 9. And in general, if you have a plus b in parentheses squared, this is equal to a squared plus 2ab plus b squared. And this is one of those things that's so basic that it's worth remembering. Yeah. Okay. So things like this, you know, these quadratic things, you want to make sure that you know how to factor, right? Factoring is a pretty big one. And then also another aspect of squaring that students have trouble with is the square root. Okay, so for instance, let's say that you have the square root of x squared. Now, if x is a positive number or a 0, then when you square it and you take the square root, you're just going to be left with x. So if x is positive or 0, greater than or equal to 0, the square root of x squared is x. So for instance, if x was, 5, and you did 5 squared, that's 25. The square root of 25 is 5. Okay? On the other hand, if x is negative, let's just do an example. Let's just say that x is negative 5. Okay, now what is this expression? So first you do x squared. So x squared is negative 5 in parentheses squared. That's negative 5 times negative 5 is 25. Now what's the square root of x squared? So the square root of x squared, well, x squared was 25. So you have the square root of 25. Now that's going to be positive 5. Remember, the square root, this symbol, okay, this is a symbol. This symbol means the positive, or it's really the positive square root. Okay. So, for 25, there's two numbers that when you square it, you get 25, right? There's 5 and negative 5. But if you say the square root, whenever someone says the square root of 25, what they mean is the positive one. In this case, it's 5. So the square root of 25 is 5. It's not, 5 and negative 5. Now notice that if x is negative 5, right, what did you get when you did the square root of x squared? You got positive 5. Okay. And positive 5, that was negative x, because x was negative 5. So negative 5 is 5. So what you ended up getting is not x, but negative x. Okay. Now, this is another thing I want to also talk about, because a lot of people think negative x is negative. Well, negative x is negative if x itself is positive. But if x itself was negative, if x is negative 5, then when you do minus that, that's going to turn it into a positive. So negative x in this case is actually positive. So the square root of x squared in general, if x is less than 0, it's going to be negative x. Okay. And in general, what is this function? If it's greater than or equal to 0, the value is x. If x is negative, the value is negative x. What's that function? What's a more common name for that function? Let's just graph this. Okay. So if x is greater than or equal to 0, it's just x. But if x is negative, it's negative x. Well, negative x looks like this. And this function is the absolute value of x. Right? So this is the y-axis, this is the x-axis. This is y equals the absolute value of x. So the square root of x squared is actually the absolute value of x. Okay? Which is equal to x if x is positive or 0, and is negative if it's negative x if x is negative. All right? And the absolute value is also something that students struggle with. So, for instance, let's say that you had something like the absolute value of x minus 3. Okay. What happens with a lot of students is they get a question with absolute value on the test. And what a lot of students do is they basically don't know what to do, and they just pretend that the absolute value just isn't there. They just pretend it's not there. And that's not correct, right? The absolute value actually does something. What the absolute value does is it turns all the negative values into positive. Okay. If what you're taking the absolute value of, so in this case it's x minus 3. If x minus 3 is positive or 0, the absolute value doesn't do anything, right? But if x minus 3 is negative, then the absolute value turns it into positive. Okay, let's write that down. So how would you write this? How would you express the absolute value of x minus 3 without using the absolute value sign? Okay. So if x minus 3, right? X minus 3 is the thing inside the absolute value. This thing. If that is greater than or equal to 0, then the absolute value of x minus 3 is just x minus 3, because the absolute value doesn't do anything. On the other hand, if x minus 3 is negative, then the absolute value of x minus 3 is negative that. So it's minus parentheses x minus 3. Okay? Well, so let's read this out loud. If x minus 3 is greater than or equal to 0, okay, what's a more typical way of writing that? If x minus 3 is greater than or equal to 0, what does that say about x? Well, you add 3 to both sides, that's x is greater than or equal to 3. Then the absolute value of x minus 3 is x minus 3. Okay, so let's just write that out. So the absolute value of x minus 3 is, see, there's two possibilities. If x is greater than or equal to 3, then this expression is x minus 3. Okay. If, on the other hand, x minus 3 is negative, so what does that mean? Okay. What x's will that be? Add 3 to both sides. X is less than 3, in other words. Then, so if x is less than 3, then this expression is minus, in parentheses, x minus 3. And if you distribute the minus sign, you get negative x plus 3. Okay, so this is the kind of stuff you have to be able to do when you have absolute values. You need to know, okay, when you have an absolute value of some expression, right? You have to know, okay, when the inside is bigger than or equal to 0, I don't do anything. The absolute value doesn't do anything. But if the thing on the inside is negative, then the absolute value sign multiplies that number by minus 1. Okay, so this is an important skill to be able to do, to be able to get from, basically to be able to say this. Okay. And where this shows up is if you have a limit. So I can even talk about that. So for instance, where you see this, one instance of where you see this is if you had, say, the limit as x goes to 3 of the absolute value of x minus 3 over x minus 3. Something like that. Okay. So here, what you have to do is you have to split up the function, because I have an absolute value. I have this. I need to know how to split that up. And basically what's going on is if you use this fact above, this fact, okay, this one, right? Okay, so let's look at this expression. So if x is bigger than or equal to 3, what is this expression? Well, the top is just x minus 3, right? So then I just have x minus 3 over x minus 3, and that's equal to 1. Oh, I guess it's undefined when x is equal to 3. So it's really when x is bigger than 3. Okay. Is this correct? Nope. What was the color I used? Oh yeah, okay. If x is greater than 3, then I get 1. On the other hand, if x is less than 3, what is this expression? Okay, that we're trying to figure out what it is. Well, okay, just look what it says. If x is less than 3, you get negative x plus 3. Okay, let's write that as negative in parentheses x plus 3 all over x minus 3. Just rewrite the whole thing. And what is this equal to? How do I simplify this? So this is equal to negative 1. Because, okay, why is this? Because I have a negative 1, okay, times x minus 3, and then over x minus 3. So again, I have a factor. See, this is the recurring pattern. I have a factor of x minus 3 on the top and a factor of x minus 3 on the bottom, because this is really x minus 3 times 1, right? And now I can cancel out the x minus 3s. And I get negative 1 over 1, that's negative 1. Okay. So it turns out that this limit And I'm assuming that you know, don't know what this limit is. You don't need to know what this is yet. But basically, it doesn't exist when you have something like this. Because this, what this function is, let's say you want to graph this function. Okay. Well, what we saw is, well, first of all, it's undefined when x is 3, right? Because you just get 0 over 0. But when x is, so here's 3. So when x is bigger than 3, it's equal to 1. And when x is less than 3, it's negative 1. So that's what the graph is. This is just equal to 1 when x is bigger than 3 and negative 1 when x is less than 3. Okay. So that's something that a lot of students aren't familiar with. I mean, a lot of students struggle with questions like this, you know, a typical exam. So this is like a first midterm question. So oftentimes the first midterm in a semester, okay, if you have a semester class and there's 2 midterms and a final, usually there's going to be limits and derivatives on the first midterm. And then there's going to be like applications of derivatives on the second midterm, and just more complicated derivative rules on the second midterm. And then on the final, I guess, will be cumulative, right? And there will be stuff on integrals. And so a typical first midterm question, there's usually a question like calculate these limits, and there will be a bunch of different limits and you have to calculate them. And then a typical question is something like this. I mean, this is actually the easier one with absolute value, because there are more complicated ones where you actually have to like factor in addition to having an absolute value. So just being able to work with absolute value like this is really important. And just knowing that you have to break it up into different cases and stuff. You basically want to rewrite this expression that you're finding the limit of, or that you're working with, without having to use the absolute value sign. And this is what we did in this example. Okay, so maybe I'll make another video where I talk more about common mistakes that students make and things that students need to know. But this video has been going on for a really long time, so I will stop.